Right, so we're continuing with curve sketching today. So last time we looked at the different types of curve, and today we're going to look at how we can transform them, mainly looking at stretching and translating. Okay, so right, so most of the functions that you'll encounter in your A-level will be lines, quadratics, cubics, quartics, reciprocals, e to the x, log of x, and trigonometric acids, if you haven't looked at it yet. That have been transformed. So most of the things we do will be these ideas, but transformed to look differently or act differently. And we're going to be using function notation. So function notation, basically you say y equals f of x, so y is a function that depends on x, and we can use that to try and show what these transformations are a bit easier and try and spot whether they're affecting the x's or the y's. So start off with the easiest bit, which is translations. So first type of translation is a vertical translation. So we see we've got y equals the original function, and then we put plus a on the end of it. And what that's going to do is it's going to add a to every y value, and by doing that, it's going to have the effect that the graph moves up by a. So if our original function was y equals x squared, so original function f of x is x squared, so function notation, our function is x squared. Well, then our translated function so if we say f of x plus a, let's use x squared plus 2. It's going to be the x squared graph moved up by 2. So we can say that's f of x plus 2. Cool. Right, now, the way we tell if it's vertical or horizontal if it is if it's inside or outside the function. And the way I was about to do that is to say, well, if you can see the original function and put a circle around it without affecting your transformation, it's outside the function and therefore it affects y. So there's our original function. There it is, plus 2. So plus 2 is outside the function, so we know it affects the vertical or the y-axis. So I said they're outside of the function. There's the function, it's outside. So quick couple of examples of that. Outside of the function, and there's the function, the minus 2 is outside or outside our original function. Okay, so that's on vertical translations. Now we're going to look at horizontal translations. So something like that. So you can see the difference now. This one is outside the function, this one is clearly part of the function. So let's see how that looks. So they're just saying that the translation is inside the function, i.e. it's with the x, so we know it affects the x-axis. Now, this gets a little bit confusing. Whereas this one meant a vertical translation of positive a. This one means a horizontal translation of minus a. So although there's a plus there, it's the opposite, and that happens a lot when we're talking about stuff that affects the x-axis, stuff that's inside the function. It always does the opposite to what we expect. So this transformation is going to move the graph to the left by a, despite the fact you'd think it was adding it to the right. So we'll try some examples of this. So x minus 2 squared, well, the original graph was a x squared graph, but we've said if f of x is x squared, we've now got f of x minus 2. So it's a translation of 2, or plus 2, in the horizontal direction. So if our x squared was here, it's going to move across 2, and then correct that instead. Okay, try another one. The original graph looks like this. We've moved this 3 in the positive direction. So now crosses at 4, so that shape moved across that B. Cool. Right, so let's try this example. So we've got an original function. We want to sketch f of x minus 3. Now, minus 3 then is inside the function, so it's going to move f of x to the right, because remember it's the opposite sign, by plus 3. If we wanted to sketch the original function, or if we wanted to write it out, we could say f of x minus 3 is x minus 3 plus x minus 3 minus 2. So we've changed all the x's in our function into x minus 3's. So, next thing, let's try and sketch the original and then let's work out how it looks when it's moved. So the original function, if I try and factorise that, two numbers that multiply to get minus 2, add to get minus 1, so we're going to get 2 and minus 1. So the original function has a root at 1 and a root at minus 2. Something like that. If we're moving it to the right by 3, this point's going to become 4. This point is going to become positive 1. So we can see our quadratic is moved to the right by 3. Right, so to summarise then, we've got vertical transformation, f of x plus a, and horizontal transformation f of x plus a. Remember, this one does the opposite. So this one would move the function to the left. So minus 3 in x direction, whereas this one does what it says, so move plus 3 in y direction. Okay, so it does what it says, move plus 3 in the y direction, whereas the horizontal transformation does the opposite, so we're going to move it minus, I don't know where I got 3 from. So, first one does what it says, it moves plus a in the y direction, so it's going to move up by a. F of x plus a inside, so it does affects the horizontal, it does the opposite, so we're going to move minus a in the x direction. Okay, so let's try a few of these. Okay, so a few examples here. If you guys want to pause the video and give it a go. So first part is to work out what the graph originally was, what the original f of x function was. Then decide if the change is inside or outside the original function, and then work out what to do. Okay, so pause the video now. Right, so the first one, so our original function in this case was a 1 over x squared graph. So a quick recap of what 1 over x squared graph looks like. It's one of these. So we have to sketch 1 over x plus 3 squared. So that is going to be a horizontal transformation because the 3 is with the x, not outside the function. And it's going to do the opposite of what it says. It's going to move root minus 3 in the x direction. So move 3 to the left. So that shape needs to move this way. So our asymptote is going to move here. And then we're going to get something like that, where this point is minus 3. Okay, next one. So 1 over x graph with a plus 5 in the end. So our original function, remember you can kind of draw a circle around it if you want. Our original function is 1 over x, which, as a reminder, looks like that. So we need to move that shape up by 5. So our asymptote is going to move up 5 first of all. So bit 5. Other asymptote doesn't change because it's only affecting the vertical points, and it's going to move the whole thing up by 5. Give us a curve that looks like that. Okay, last one's a bit different. They're given an original function, we don't know what it is, some sort of cubic, and we're asked to sketch f of x plus 3, so move the whole graph up by 3. So our new function we sat on the axis there, so this point has moved up to here, this point has moved up to here. Cool. Right, we're going to move on to stretches now, which is the other type of transformation we're going to be looking at today. Stretches, so this is going to stretch the shape in the horizontal and vertical axes. So first up, vertical stretches. So we got y equals a f of x, y equals 1 over a f of x. So notice again, like in the transformations, the transform we're looking at is outside the function. Again, if you wanted, you could draw a circle around the original function. Here again, outside the function. So here we've got a stretch. So stretch the y coordinates by scale factor a. So basically, in kind of plain English, we are multiplying. So multiply y values by a, which is going to result in a stretch. And for one like this, well, it's obviously going to be divide. So stretch y coordinates by scale factor. So stretch the y coordinates by scale factor 1 over a, which is basically asking you to divide the y values by a. So it's going to squash it in vertical. Instead of saying squash, we still call it a stretch, but it's a stretch by a fractional scale factor, so it's going to get smaller. So here we've got a function f of x, and we want to sketch the stretched version of this. So there's a 2 outside, so I know we're going to multiply all the y coordinates by 2, and it's going to stretch it in the y direction. All that's going to do, because it's quite hard to draw these, it's going to make it look more exaggerated, so that point that's 2 is now at -4 because it's been stretched. Okay, one more example. Okay, so this time we've got an exponential graph with a transformation, and notice I can still put a circle around the original function. Nothing's changed in that, so this again is outside the function. So this is a vertical stretch from a fifth, which is technically squashing it, so it's going to get smaller. So e to the x used to look like this. Going through 1. So our squashed version, same kind of shape, but that's now going to be a fifth instead of an asymptote there. So you've squashed the original shape. Notice my sketch is the same. It's really hard to draw these. That's why we have to label points so that you can see something's actually happened. Right, on to horizontal stretches. Okay, so horizontal stretches, again inside the function, and it's again going to do the opposite of what you think. So inside there, looks like you're multiplying it by a. No, we're going to stretch it by 1 over a. So in other words, so we divide the x values by a, and that's going to make it look squashed. Okay, the other type like this, when you've got x divided by a, is going to be the opposite again, so stretch. So we're stretching it by scale factor a. So this time we're doing the opposite. It looks like we're dividing, so we're now multiplying. So we're multiplying those x values, those x coordinates, by a. So that one is stretching it bigger. Okay, let's try a quick example of this. So if that's our original function, y equals f of x, which is some kind of a quartic, we're now going to sketch y equals f of 2x. So it's inside, so it's going to affect the horizontal axis, the x coordinates. and it looks like times by 2. We know it does the opposite because it's inside, so we're going to half all those x coordinates and squash it. So our coordinates would then be -2, 1, 2 and 3. So it's gone from that to a squashed version of that. Okay, so just to summarise then, let's try and describe the following transformations. So if you have a look through, pause the video, describe whether they're inside or outside the function, so whether they affect x or y, and whether they do what they say or whether they do the opposite. So in words, can you guys try and write in your notes what each of these transformations does? Okay, so the first one, 5x cubed, we have a 5 there, which is outside the function. I can draw a circle around the original function. So outside, so it affects y. And we're timesing it by 5. So that's going to be a stretch vertically by 5, which in other words means we're going to times all the y coordinates by 5. Okay, next one. Again, we can draw a circle around the original function. So this is outside. And again, it's going to be a stretch. We're stretching it by a half because it's a half times it. So in other words, we're going to times y coordinates by half, or you could think of it as divide the y coordinates by 2. Okay, next one. Well, this time we've got something happening inside the function. So the original function was x cubed. I can't really separate the 3 from the x cubed. So it's inside. It's going to affect our x coordinates. And it says add 3. We know it's going to be the opposite. So we're going to translate by -3 horizontally. In other words, subtract 3 from our x values. Okay, next one. Again, we can draw a circle around the original function, so it's going to be outside. It says add 4, and that's what we're going to do. So translate +4 in vertical direction. In other words, add 4 to y coordinates. Okay, next one. So here we have, again, you could argue this is outside, but this is inside the function. It's part of the x bit. So you've got e to the power of x take 2. If it was vertical, just to show you, you put -2 on the end of e to the x. So this is inside, therefore it affects x, and it's going to do the opposite to what it says. So it says take 2, we're going to add 2. So translate by +2, which in other words is add 2 to the x coordinates. Right, next one, so there's our original function, so we can see it's outside. So we're going to translate vertically by -3, which in other words means take 3 from our y coordinates. Okay, last 2. So again, here's our function. The 2 is part of the x there. It's inside the function with the x. So it's going to be a stretch. It says times by 2. It's inside, so it's going to be the opposite. So stretch by a half, which in other words means divide x values by 2. So it's actually being squashed. Okay, last one. So we got -3 in both of these. What this function used to look like was x squared plus 2x plus 1. So we can say, well, every place it's had x written, we've now got x minus 3. Therefore, it's inside the function. If it was outside, it'd just be on the end here. We put it inside with all the x's. So it says take away 3. We know it's going to be the opposite. So we're going to translate by +3. So translate by +3 in the x direction, which in other words means add 3 to our x values. Cool, right, quick summary there. So have a read through those. If you did get any wrong, maybe go back, look through the relevant bit of the video, and then move on to this week's or this lecture's quiz.